Welcome to A Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's lesson, we will talk about Doppler effect. I'll explain you what exactly Doppler effect is, what are Doppler effect equations, and how we can use these equations to answer past paper questions. Let's try to understand what is Doppler effect. Doppler effect is simply the apparent change in the pitch of the waves, and that is simply caused by relative motion between the source and observer. Mean is the apparent change. Apparent change means this is the change for listener, but the original frequency of sound waves is not changing. If we look at this truck, for example, you can see the truck here as it is given in the example. You can see as this truck is at rest and this truck is not moving. As the truck is not moving, the listener standing here and listener standing here, they will perceive the same frequency. Doppler effect is all about relative motion between listener and source. If there is no relative motion between listener and source, there will be no Doppler effect. So we have to be very clear. There must be relative motion between listener and source. Let's try to understand when the truck is moving. As we can see here, truck is here and this truck is moving to the right. There is one female, she is standing in front of the truck, and there is a male who is standing behind truck. As the truck is approaching to the female, so this female will perceive higher frequency, or we can say higher pitch, and this person standing at the back will perceive lower pitch. The reason is that the person standing in front of the truck will receive more number of waves in a given time, means the number of waves he is receiving per second will increase, so he will perceive higher frequency, and the person standing at the back will perceive lower frequency because he will receive less number of waves per second. So this is simply all about relative motion. If source of sound is approaching, frequency or the pitch will go higher. If the source is moving away, then pitch will go down or pitch will decrease. It's just due to number of waves listener is receiving per second. Let's try to understand when the source is approaching and the listener is at rest, means the listener is not moving at all. As the source is approaching, it simply means that the listener will receive more number of waves per second. So he will perceive higher pitch or higher frequency. So how we can calculate that observed frequency by listener? So f prime is observed frequency by listener, and f is the frequency of sound waves produced by source, and v here is the speed of sound waves, and us is the speed of source. If these things are given to us, you just simply need to plug in and you can find out observed frequency. As we can see in this case, this is minus. Why we are using minus here? Because the source is approaching, so the observed frequency will be higher than source frequency. That's the reason we have minus sign here. So when source is approaching and the listener is at rest, you simply need to use minus because observed frequency has to be higher. Let's try to understand when the source is moving away from listener and the listener is at rest. So you can see here, as in this diagram, our source is moving to the right. So here is source, it is moving to the right, and the listener is standing on the left side, and the listener is at rest. So in this case, we can simply understand the number of waves this person will be receiving, listener per second, will go on decreasing. So he will perceive lower pitch. And how we can calculate the frequency he will perceive, that frequency we can call f prime, or we can also call observed frequency, means the frequency he will observe. And this is the frequency of the source, and here v is the speed of the sound waves in the medium, but this u s sub s is the speed of source. In this case, observed frequency will decrease. That's the reason we're using plus sign here. Let me explain to you how to use Doppler equations. The first one is only for moving observer, or you can say for moving listener, when the source is at rest. If the source is at rest and only listener is moving, you can use this equation and you can calculate the observed frequency. So if the listener is approaching, then you have to use plus sign here. And if the listener is moving away, you have to use minus sign here. Plus sign when it is approaching, simply because the observed frequency will be higher, and when the listener is moving away, he will perceive lower pitch. That's the reason we are using minus sign here. And the second one is for moving source, means when only the source is moving and observer or listener is at rest. By using this one, we can calculate observed frequency. This frequency, when you are calculating, you need to be careful. You need to check, is the source is moving away or is the source is approaching. If the source is moving away, we will use plus sign here, means we will add these two speeds. And when the source is approaching, we will use minus sign here. So when the source is approaching, observed frequency will be higher, so we will subtract u sub s from speed of waves. So this is all about Doppler effect. This is how you need to use these equations. Get familiar with these sign conventions. Here is question from Cambridge AS Physics, and this question is based on Doppler effect. Let's try to apply our understanding of Doppler effect and Doppler equations to answer this question. So you can pause this video. First of all, you can try this question by yourself, and then you can come back and you can compare your answer with my answer. If we read this question, it is given to us that the frequency of source is 1000 Hertz. We can say this is frequency of source, and the source is moving at speed 20 meters per second. We can say this is speed of source, and the source is approaching observer, and observer is at rest, and the speed of sound in the air is given here. What we need to find out, simply we need to find out observed frequency, means the expression. We don't need to solve, we simply need to write the expression for that. So from our understanding of Doppler effect, we can simply write down the equation when the source is moving and the listener is at rest. So this is what we have discussed when the source is moving. So this was our equation when the source was only moving and listener was at rest. But now we need to understand whether we use positive sign here or negative sign here. In the question, it is given to us the source is approaching. Source is approaching, so it simply means that observed frequency will be higher. Means the listener will perceive higher pitch. Listener will perceive higher pitch. So higher pitch is only possible when we use minus sign here. So our equation when the source is approaching, we can write down will be speed of sound minus speed of source multiplied by frequency of source. In this case, the speed of sound is here. This is v. So we can write down the speed of sound in the medium divided by speed of sound minus speed of source. So this is speed of source, and we simply just need to multiply with frequency of source. So in this case, frequency of source is 1000. So we can simply write down here frequency of source is 1000. So in this case, our answer will be B. So this is our final answer, and this is how we can use Doppler equations.